All right, so today the plan is briefly tell you what the test looks like. And I mean really briefly, like there it is. It's not much of a test outline, but it's not much of a, there's not a lot of different things going on. And really, it used to be a block day test, so now it's just split up into two parts. So part one is 17 multiple choice questions, 3 points each, that makes 51. Part two, 10 multiple choice questions, 4 free response questions, for a total of 97, so there's a few free points in there. There will be a bonus. I'll curve it if needed, but I'll make that decision after I see what the grades are. As I did the key over the long weekend, I was like making notes on the side, like, ooh, that one's kind of tricky. Oh, that one's kind of whatever. Oh, make sure we pay attention to that one. And then I went and checked and compared it against the review, and it's like, oh, they're all there. So in my mind, if you can do the review, which is lengthy and comprehensive, but if you can handle the review, you can handle the test. So what we're going to do today is that procedure where first period I'm going to work every third one, and then second period I'll work every third one, different thirds of course, and then fifth period I'll work every third one. And by the end of the day, there'll be 3 videos posted on YouTube. And so you'll have seen me work a third of them in class, and then you can go watch the other 2 videos if you need to. So I think that's the best way to go. That way, everybody gets a third of the review in person, and everybody gets the full review if they want it. So let's get the review out. Oh, one more thing. I'll make the homework packet due on Friday. Right, I mean, in theory, you ought to have it done. You ought to have most of it done already, and you definitely should have all of it done by Thursday, tomorrow. But I know that some of you, this is a crazy thought, but some of you might want to study more between Thursday and Friday, and having the homework with you would be helpful. A few of you are like, nope, not gonna. That's fine, but some of you might. And so I don't want to take review materials away from you that you could be using to study for the test. So homework will be due on Friday. Okay, any questions on what's going down this week? I feel like our adjustment is pretty easy, so hope you enjoyed your day off yesterday. All right, so look at the review worksheet. And, it's already divided into thirds for me. So this will be the first period column and the second period column and the fifth period column. Some are easy, some are hard. And it's like that on the test. Like some are like 2 seconds. Like, oh, that's an easy one. And others are like, whoa, wait a minute. Arc secant and inverse secant. Like, I mean, think a minute. But let's just do the review. And as always, stop me if you got questions. Ask. And we'll slow down if we need to. All right, number 1. Integral of e to the 2x. I'm going to split this up. I can do this into 2 parts. You probably wouldn't even write this down, but kind of show my work here. E to the 2x. Many of you would probably pass on doing u substitution on that one. Like you'd be like, yeah, the integral is going to be e to the 2x. I just got to figure out the constant thing. And so if you can figure it out on your own, fine. If you want to write it down, that's fine too. We'd make u be the exponent. Du gets us a 2. So let's put a 2 on there and a 1/2 out front. And so this is now the integral of e to the u du with the 1/2 out front. So 1/2 e to the 2x. I could put plus c, but I'm going to wait until the end and put plus c. There's no need to put it on both of them. And again, I think, in fact, I hope that some of you would skip the u substitution on that one. You would just figure out that you needed a 1/2 there to make the 2 cancel out from the chain rule. Okay, this next part looks weird. Like what is e to the pi? Not like what is its value. I don't know what its value is, but what kind of number is that? It's a constant. So I don't know what it is, but it's just a constant. So it would integrate the same way if there was just like 3 dx in there. So what's the antiderivative of 3 dx? Who has a derivative of 3? 3x. So who has a derivative of e to the pi? Well, e to the pi times x. So it looks funny and weird, but e to the pi is just a number. So its antiderivative is that number times x. And then don't forget the plus c here at the end. All right, number 4, we start getting into the, be careful situation, because that kind of looks like the antiderivative, or excuse me, this looks like the derivative of arctangent, kind of. In fact, 4 and 7 are good ones to compare. But this one kind of looks like the derivative of arctangent as well. So between 4 and 7, do you know which one is the arctangent? 7's arctangent because it doesn't have that x in the top. Which means I'm not exactly sure what number 4 is, but I think if I let u be the bottom, then du shows up in the top. We like when that happens. Spawn an extra constant in there. So 1/2 antiderivative 1 over u du. And that should ring bells. That is natural log. So 1/2 natural log. Don't forget absolute value. Most of the time it doesn't matter. Like if you left it off, like you'd still be able to pick out the right choice. There is definitely a problem on the test where you got to have the absolute value because the limits are negative. And so if you leave them off, it feels wrong because you can't log a negative number. But if you remember that you've got to have the absolute value, then you'd be okay. So 1/2 natural log of u plus c. Remember that is okay for a free response answer. And there are a few free response answers, and there are u substitutions on the free response. So you could leave it like that and be fine. In fact, when I made the key, like I ended up boxing in like 3 or 4 things. Like all of these things are acceptable. Like that's fine. Multiple choice, they're going to substitute x squared plus 2 back in there. And in fact, since x squared plus 2 is always positive, they would probably not use the absolute value bars and just use parentheses. So I imagine that one is the best multiple choice answer. But again, if you made it to here, it's not too hard to get from here to here. Okay, 7 doesn't have an x in the top, so if you tried to let u be the bottom, then du would have an x in there, and that wouldn't work. So hopefully you're to the point where you can do that kind of in your head, and rather than write it down. But it's u substitution, so sometimes you misfire, and so you start writing things down that don't really work. So you could try it, and you're like, wait a minute, there's not an x up there. I'm not allowed to like spawn in an x in the top and the bottom. That only works for numbers. So that won't work. But hopefully you recognize that, wait a minute, that looks like arctangent. The 5 doesn't matter. He can come out front. I can let u be x and a be the square root of 8. And then du, I kind of wrote that backwards, but it's the same thing. Du is dx. So 5 out front. Antiderivative of du over u squared plus a squared. Now that's definitely arctangent. So 5. Arctangent has the 1 over a out front. Arctangent of u over a. And again, I could just write u over a and be fine because I've defined what u and a are. And I would leave it like that. Yeah, that square root's in the bottom. Yes, square root of 8 can simplify to 2 square root of 2. But Right? I mean, I don't want to say that's beneath us. That's not calculus. Like we've done the calculus. If you want to go further, then help yourself. 10. Again, my first thought when I see these is u substitution, but pretty quickly, if I let u be the bottom, du is 2x minus 6. That doesn't match anything, so it's not going to be a u substitution problem. So what am I going to do with this one? That's a complete the square problem. Well, maybe I just want to move the 3 out front and be done with it for now. So x squared minus 6x. Get that 14 out of the way. And then half it, square it, add it is my kind of the heart of the complete the square method. So half it is negative 3. Square it, I get 9. So plus 9 minus 9. Factor the bottom, but it always factors with b over 2. That's kind of the fun part of complete the squares. Your factoring is sort of automatically taken care of. So now this looks like u squared plus a squared. And again, maybe some of you are to the point where like, yeah, I'm not writing out u and a for that. I know what u and a are. And that's fine if you go that route. I feel like this is still kind of new to us, so I'm going to write it out. The danger of not writing it out is messing up the u and du stuff. Now this one works out, so I would have been fine. But if there was a chain rule off of that u, then I'd have to be careful. So 3 times 1 over... let's see, last time I plugged them in, so this time I'll leave them as u's and a's just to show that it can be either one. So 1 over a, arctan u over a plus c. That's more of a free response answer because I didn't plug in what u and a are. But that would be pretty easy to do on multiple choice. Plug in u, plug in a. We lost our column, so I got to keep up with what number we're on. So 13. This is very similar to a test question. What's most recent on my mind is the key, because I did that last night. And so I see this question, I'm like, oh, that rings a bell. The figure on the right shows the graph of the continuous function f. The regions A, B, C, D, E have areas 2, 14, 10, 27, and 4. Now, what do I need to be careful about when I label those areas?
The ones below are negative.
Yeah, the ones below are negative. So, again, area is never negative, so that problem is worded correctly. I just need to be very careful about that 2 and the 10 are negative. So I'm just going to label them as negative. I know that's not officially correct for their area, but I'm talking integrals, so I'm going to label them as negative. Okay, part A. Antiderivative from negative 5 to negative 1, f of 2x plus 1. Okay, well, the first thing I'm thinking is I don't have an equation to take an antiderivative of, so I'm also remembering that this means area under the curve, which obviously fits with what we have. So I'm not thinking antiderivatives as much as I'm thinking area. Right now I'm thinking area from negative 5 to negative 1. That would be negative 10, but I don't think there's 2x plus 1s in there, so I gotta do something with that. And the something I'll do with that is let u be 2x plus 1. And then du is 2 dx. So here we go again, spawning numbers to make our problem work. So I've got 1/2 antiderivative of f of u du. What do I need to do next? My next step in this problem. I got different limits or different boundaries. So my x limits were -1 and -5. I need to change those. If x is -1, then u is, let's see, -2 plus 1 is -1. So that one didn't really change. And if x is -5, then u is, let's see, -10 plus 1 is -9. So -9 to -1. That's still in order at least, so smallest to biggest. So this would be the area under f from -9 to 1. So now this is an area problem with the 1/2 out front. So from -9 to -1, my area, okay, be careful, I've got way more information than I need here. All I want is the area from -9 to -1. So I'm ignoring the rest of this graph. 14 minus 10 is 4. Obviously that's a safe stop. 1/2 of 4 is 2, so there's my best multiple choice answer. So I combined a lot of things. Antiderivative as area, making sure we know that. Changing the limits. Negative areas. U substitution, chain rule. Like, there's a lot of stuff going on in that one. Let's do one more of those. I don't want to do both of them because they're all, all three, they're all kind of the same. What do we think U should be for part B? Six minus x squared. All right, it's time for you to work one of these. So I'm gonna. That's kind of backwards, but I don't mind backwards. What's the price we pay to flip them back over? The negative, and there's already a negative there, so I could phrase it as I'm going to use this negative to flip them. And so now I just want the area from -5 to 5, and 1/2 of that. I've already marked up my graph. This time I'm looking from -5 to 5. And you can tell these are sort of rigged problems that our integrals are landing, or our boundaries are landing at good spots. Right? If we somehow got the area from 1 to 3, we wouldn't be able to do that. So, yeah, you feel good that you're on the right track, that you're hitting spots that work. So let's see, from -5 to 5, that would be -10 plus 27. So 1/2 of 17. Part C is like exactly the same thing, right? Let U be the inside. Du is 6x squared, so you need a 6 and a 1/6. And then you change the limits, and my guess is they'd land somewhere at convenient spots. 16. Or -2 to 10. Function is twice differentiable. Selected values of f prime are given in the table. Okay. All right, well, forget the table for a minute. What's the antiderivative of the second derivative? Part A, what's the antiderivative of the second derivative? The first derivative. Like, undo one of the derivatives, that gets us back to the first derivative. And then plug in 3 minus plug in 2. So f prime of 3 minus f prime of 2. And that's what the table gives us. F prime of 3 is 6. F prime of 2 is 2. 6 minus 2 is 4. So that's supposed to be an easy question, right? The antiderivative of the second derivative gets us back to the first derivative. Plug in the limits. They gave us those on the table. All good. What do you think we need to do on B? Use substitution stuff. Probably where u is that inside piece. So du is 2x. So put a 2 and a 1/2. 1/2. Antiderivative. I'm careful now, those limits. I can't write 1 and 2 because those are x limits, and I'm in the process of making this a u problem. So I need to switch those limits up. So this is actually really similar to number 13. It's just a table problem rather than a picture problem. Okay, 2 squared plus 3 would be 7. Again, I'm not showing the work that gets me the new limits, but I'm getting them, so that's okay. I plug in 1. 1 squared plus 3 is 4. So 1/2 f prime from 4 to 7. And again, you know you're on the right track if 7 and 4 are in the table. If they weren't in the table, then either the problem's wrong or I did something wrong. And remember, that's not a safe stop. You got to plug in the values, so I'm not there yet. But f prime of 7 is 11. F prime of 4 is 8. And I'm out of space, so I'll safe stop it there. And then part C is, again, the same kind of deal. You'd let u be this. du, you'd get a 2. That 5 just doesn't even need to be there, so I'd move him out front. And it'd be the same as A and B. So those are, I don't know how to phrase that. It's not, you don't have to know any tangents or secants or anything crazy, but you definitely have to know u substitution and chain rule stuff. All right, 19. Oh, speaking of trig stuff, which one does that look like? Do you know the rules well enough to recognize that one? Yeah, it's not arctangent because arctangent doesn't have a square root. Arcsecant has an x out front, and the absolute value thing, it's not that. So yeah, it's arcsine is where we're headed. That 4 is kind of messing with me, so I'm going to let u be 4x plus 1. du then is 4dx. So a 4 and a 1/4. And I don't like that negative. I'm just going to move him out front and not have to worry about that. So negative 1/4 antiderivative du square root 1 minus u squared. Yeah, that's exactly arcsine now. So negative 1/4 arcsine of u to sine doesn't, no, u over a. Although a is 1 here, so I don't really have to worry about that. But if I want to use u over a, oh, that's a, I mean, this would only be a free response issue, but why am I going to take off a point if you put that as your answer? What's up? I hadn't defined what a is. So I did define u, so that's fine, but I didn't define what a is. I mean, I knew it was 1, it was easy. But if I don't say it's 1, then I can't give you full credit on that. Let's see, number 22. Oof. 22. What? Thoughts on what that is? I don't know that we've seen one quite like that. Again, my first thought is let u be the bottom, because sometimes that works. But then the top, or then du is 2e to the 2x, and I don't have e to the 2x up there. So I can fix the 2, but I can't fix e to the x, e to the 2x, so that's out. That 2 up there makes me think squared, makes me think arctangent. So maybe I can head toward arctangent, where a is the square root of 3, and u is e to the x. Right, because if I squared e to the x, I'd get e to the 2x. And then now du is exactly what we have. So this might be one of those that if you hadn't seen the teacher do it, I don't know, would you have come up with that or seen that? Okay, now it looks exactly like arctangent. Arctangent has the 1 over a out front. Okay, let me slow down. Am I missing a spawning number? No, I did not have to spawn anything because it all worked out. So 1 over a, arctangent of u over a, plus c, and I don't have to worry about, let's see, I defined who a is, I defined who u is, so that's fine. Fine for free response. I'm going to go ahead and do one more of these where I write it out because most of the test is multiple choice, and multiple choice is going to plug those pieces back in there. Again, if you make it this far, you're not going to have a problem making it to the next step, but just to make sure. Alright, it's 25. That's one we just have to know. Back 25, 26, 27, we just have to know those. If you don't remember, here's how I remember it. It's that. I derive this one usually because I don't remember if it's sine or cosine or positive or negative. So if I let u be cosine of x, du is negative sine of x, and now I remember that it does have a negative, and this ends up being du over u, which is natural log of the absolute value of cosine. So there's my answer, plus c. What else about that one? Oh, sometimes people get tricky, and they, again, free response, stop here. Like, there's no reason that that's a perfectly fine answer. If you want to get tricky, then you put that negative as an exponent, and cosine of the negative 1 flips the cosine, which turns it into secant. No way you would do that on your own. No way you should do that if you were working this problem. But on a multiple choice test, if you pay attention, that will happen. How about that? Instead of that could happen, that will happen. Secant and cotangent, man, I'd have to remember those. Whatever those are weird ones. But we have to have them memorized. So 25, 28, 31. If f of x is inverse sine, then the derivative at root 3 over 2. Okay, well, so find the derivative first and then plug in root 3 over 2. Let's see. Derivative of arc sine, that's 1 over, because they all start that way. Sine and secant have the square root. Sine doesn't have the extra number out front, or the absolute value of x out front. And let's see, sine is a small number, so it's 1 minus x squared. There we go. Secant is the one that's x squared minus 1. Tangent is plus, so it doesn't matter what order you put them in. All right, so let's plug in root 3 over 2. Obviously, we're going to have fractions and fractions. Yuck. If I square that, I'd get 3/4. Pretty sure my answer is going to be D, just because A and B would be if you just did the inverse sine of root 3 over 2, you'd get pi over 3, but that's not with the derivative. I don't see how I'm going to get 4/7 out of here. 1 minus 3/4 is 1/4. Here we go. This one worked out. Square root of 1/4 is 1/2. And 1 over 1/2 is 2. That's a whole lot of a little algebra there at the end of that one. If this appeared on a free response, right, you'd be good to stop there, because that's fine. So again, don't take it further than you have to. Derivative of 31. Derivative of cosecant. Okay, derivative of what's the difference between derivative of secant and derivative of cosecant? Just the negative. So I definitely don't know the derivative of cosecant, but it's just negative whatever the derivative of secant is. So they're all 1 over. Secant has that absolute value of the argument out front. And then square root. And this one, it's e to the x. It's the argument squared minus 1. And then chain rule, derivative of e to the x is just e to the x. So there's my answer. D looks like an antiderivative type answer. Okay. Let's see. E to the x and e to the x can cancel. E to the x is always positive, so I don't have to worry about the absolute value there. So those will cancel. So they're all negative. That got canceled, so he's not there anymore. That one would be if we... That's probably sine, maybe? I don't know. But it looks like it's answer choice A. Okay. That's all the scheduled ones for first period. So watch the other videos for other answers.